Once again, we're working on our Chapter 3 notes, examples, that is, the problems that are in our notes. We're working on free fall, and this is going to be example number 6. So example number 6, right here. We've got a person stepping off of a diving board, or it would appear that it would be a high diving board because it's 3 meters high, and they drop into the water below. So right off the bat, our displacement is going to be 3 meters, but they're going to be going downward, so it's going to be negative 3 meters. So I should put a negative in front of that right there. And do we know anything else? Well, we're not told anything else, but we know that the acceleration of gravity is going to be negative 9.81 meters per second. Negative 9.81 meters per second squared. And they're dropping down. Let's pretend that, or at least let's assume that the person is simply stepping off the diving board. So what is their initial velocity? That means it's going to be 0 meters per second. They're not jumping off of it or jumping up and then down, but they're just stepping off the diving board and dropping straight into the water. So with that assumption, we can assume that the initial velocity is 0. And what we're asked in part A is, how long does it take? That is, what's the time that that person takes to drop into the water? Do we know anything else? We don't quite just yet, but we can figure this out. We have our equation where we have our displacement is equal to the initial velocity times time plus 1/2 times acceleration times time squared. And we're solving for time right here. Now, it would appear that this is a quadratic because we're solving for time. Solve for time because we've got time squared here and then time, so must be quadratic, right? Well, it would be, but if we go one step further and actually substitute in our values, we're going to find that right here, that's going to go away because our initial velocity is 0. So if you just look ahead a little bit, sometimes, a lot of times you can save yourself some work by making some values drop out. So since that will be equal to 0, we're basically going to have our displacement equals 1/2 AT squared. So now let's solve for t. Let's get t all by itself here. So I'm gonna multiply both sides by 2, right? Because I've got 1/2 on the one side, so it's going to be 2 times delta y, and on the left hand side, and I'm going to divide by a on both sides because I've got the a right here multiplied by the t. So divide by a, and that's going to equal t squared, and of course I undo the square simply by taking the square root. So t equals the square root of all that, 2 times delta y over acceleration, or 2 times our displacement. Now here's where it's important to make sure we get our signs right. We all know that you can't have a square root of a negative number, so we need to make sure that all of our signs make the value inside the square root sign positive. So that's going to be square root of 2 times, what's our delta y? Well, our change in displacement is negative 3 meters. That over negative 9.81 meters per second squared. That will give us a positive value inside the square root, and then we can solve for t. So t is going to be equal to 0.78 seconds. So about 3/4 of a second it takes that person to drop from 3 meters above the water down to the water. That's part A right there that we just solved. Let's do part B now. Part B, the question is, what's the final velocity? Our VF is what? Let me write it in here. VF is, we don't know. Well, we do know our initial velocity. We know our acceleration, our displacement. We even know our time, but I'm going to try to find an equation that does not depend on time. Now, sometimes you'll have to do this. use an answer from a previous part of the question to solve the next part. But if you don't have to, don't, because what if I got this wrong right here? Well, that would make my second part wrong. So let's try to find an equation that does not use time. And I think we can do that. We have our final velocity squared equals initial velocity squared plus 2 times acceleration times our displacement. So it's just about already solved for final velocity. All we need to do is get rid of that square right there. Final velocity is equal to the square root of vi squared plus 2 times a times the displacement. So we got the square root of, what's our vi? Well, that's easy too, because that's 0 plus 2 times negative 9.81 meters per second squared times our displacement, negative 3 meters. So initially it looked like that would be a negative inside the square root, but a negative times a negative means a positive inside the square root, and so that means we can actually take the square root of that. So what's the square root of all that? That would be 7.7 meters per second. So after the person has fallen for 3/4 of a second down from 3 meters above water, they hit the water at a velocity of 7.7 meters per second. That's our Chapter 3 notes, example number 6.